Good morning, doctors. Today, we're from small group discussion B2. We'll presentate our student project that entitled Carbapenem Resistant Enterobacteria. Before that, I will introduce the name of our members from small group discussion B2. And here is the list of our members. We hope you can enjoy our presentation.
Hello! Do you guys know what is Enterobacteriaceae? Well, it's one of the families of various species of bacteria that are highly infectious to humans, although some species are part of the normal flora. The disease infections that can be caused by this family of bacteria include duct infections, urinary tract infections, inflammations of the membrane of the brain, and septicemia.
Now, I will explain about the carbapenem antibiotics. So, carbapenem antibiotics are considered as the general potent group of antimicrobial agents that have been used for patients' treatment with severe bacterial infections. This antimicrobial agent's efficacy has been proven including on those caused by otherwise antimicrobial resistant strains. Carbapenem antibiotics also reported was used to treat serious gram-negative bacteria or GNB infections. However, carbapenemase-producing strains of GNB appears as a major source of resistance. That's all from me. My friend will tell you the next part.
Hello, I will continue to explain the definition of Carbapenem Resistant Enterobacteriaceae, or also known as CRE. The emergence of carbapenem-resistant bacteria is considered to be increasing their prevalence into the community from healthcare setting, which made a serious current public health concerns. Enterobacteriaceae, able to adapt to selective pressures in the presence of carbapenems, which highly prove in the treatment of ESBL, producing K. pneumonia infections in 1980s. CRE, caused by the strains that produce metallo-beta-lactamase, IMP1, which made them able to hydrolyze carbapenems and could transfer from one species to another through their plasmids.
The next one is epidemiology. Carbapenem resistant Enterobacteriaceae or CRE infections are associated with high rates of morbidity and mortality, especially in patients with compromised immune systems, and the effective treatment is still limited. The distribution of this bacteria by horizontal transfer of genes that encode carbapenem hydrolyzing carbapenemase enzymes. Porine mutations and overexpression of efflux pump also lead to carbapenem resistance in combination with the hyperproduction of beta-lactamase enzymes, which inactivate carbapenems and other beta-lactam antibiotics. The carbapenemase enzymes are produced in plasmid medium, and the conjugative plasmids carry additional genes that confer resistance to other antibiotics such as fluoroquinolones and aminoglycosides.
For the spreading mechanism, Carbapenem resistant Enterobacteriaceae spreads in three different ways. The first one is physical contact, such as wounds and stool, from the infected people. The second one is contaminated stuff, such as sink drainage, toilets, and medical equipment that is unsterilized. And the last one is body fluid, from the mucus, saliva, blood, and urine.
Okay, now we are going to the genes related to CRE. The Center for Disease Control say that CRE is one of the biggest challenges in antibiotic resistance in public health. This is because CRE causes the acquisition of the carbase gene. Tests to find genes in CRE are carried out in several ways. One of them is PCR examination. On PCR examination, it was found that CRE contains several genes. There are beta-lactam KPC in Enterobacter cloacae, Escherichia coli, and Citrobacter fendii, beta-lactam NDM in Escherichia coli, beta-lactam IMP in Klebsiella pneumoniae, beta-lactam VIM in Pseudomonas aeruginosa and Acinetobacter baumannii, and beta-lactam OXA40H in Klebsiella pneumoniae and Escherichia coli.
In addition to PCR, ESBL examination were also carried out.
With ESBL examination, the researchers found that the CTXM and TEM genes were found in Enterobacter cloceae and Citrobacter verandae isolates, and CHV, which was mostly found in isolates Capsella pneumonia. The next examination was with AMPC cephalosporinase. In the AMPC cephalosporinase examination, CMY, ACT, and DHA were found in isolate Enterobacter cloceae. Another examination, namely mutation in the purine coding gene, found OMPK35, OMPK36, or MPC contained in CRE. Increased resistance to oxymino and zwitterinic cephalosporin was associated with OMPK36, particularly in ASBL producing strain. In addition, OMPK36 is also related to cefoxitin resistant and carbapenem resistant that produce plasmid-mediated AMPC type lactamase in the strain.
The Carbapenem Resistant Enterobacteriaceae can transfer their Carbapenem resistant gene to the other Enterobacteriaceae through conjugation. Conjugation is one of the gene transferring process that conducted through direct physical contact from the donor cell to the recipient cell. The conjugation usually occurs by the transfer of gene mediated by plasmid from the donor bacteria or F positive to the recipient bacteria or F negative. The mechanism initiated by the surface contact of F pilus from the donor to the envelope from recipient. At first, the surface contact associates both cells into aggregate that reflect the pilus retraction reflex, followed by pilus depolymerization of donor cell into recipient cell.
Next is push-out mechanism for DNA transfer. The DNA can be pushed out from one donor cell to the recipient cell during bacterial conjugation. Depends on a large membrane-associated protein complex that belongs to the type 4 secretion system or T4SS. The conjugative DNA molecules encode a group of proteins through the membrane channels that form IM, periplasm, and OM, which will code the conjugative ssDNA, which will be supported by energy from valence B4, valence B4, and B11. The ssDNA, a group of membranes and periplasmic proteins, will form a large complex that divided into four. The first at distal end, and then the OM components. Third one is valence B8, B10, and B6 as perisplasmic components. And the last one is valence B3, valence B6, B8, and B10 as IM components.
So now, let me explain about Carbapenem Resistant Enterobacteriaceae disease. So CRE can cause various types of disease in various types of organ based on which bacteria and also the site of infection. Most common patients are suffering from pneumonia, which are infected by CRE. Other than that, CRE can also cause lung infection, where it might produce a pocket in lungs which contain bacteria and also fluid, or known as lung abscess. Other than that, CRE can also infect human bloodstream and cause sepsis. So sepsis is a serious disease that may lower the blood flow into visceral organ, and it may cause death. Other than that, CRA can also cause many types of infection. For example, urinary tract infection, intra-abdominal infection, and also wound infection. Thank you.
Now, I will explain the prevention for disease that caused by CRE. Prevention is an important phase that used to minimize the spread of CRE. The most important thing to prevent CRE is cleanliness. By having a clean environment, we can prevent the transmission of the bacteria. There are some methods to prevent the transmission of CRE. First, the medical device should be cleaned conscientiously and sterilized. After sterilized, the medical device should be handled to the trained personnel to maintain a clean workspace. Second, when the medic entering the room of a person with CRE, they should wear gown and gloves to prevent the bacteria's transmission. Third, everyone, either medic or society, should wash their hands by using soap and water or use alcohol-based hand sanitizer. And the last one is by limiting the use of antibiotics. Antibiotics should be used carefully and use as prescribed.
Okay, next, treatment for CRE. Antibiotics option for the treatment of CRE are very limited because CRE has high resistance to the carbapenem class of antibiotics. And currently, the antibiotics that used to medicate CRE are tigecycline. Tigecycline, which was approved by the Food and Drug Administration in 2005, and then colistin and fosfomycin. So there are the old antibiotics which have been revived, and then aminoglycoside. Aminoglycosides are among the remaining treatment options for clinicians to battle these difficult to treat infections. And some things can be done as well to relieve symptoms and strengthen the body to fight infection, include trying nutritional therapy, trying other antimicrobial treatments, taking intravenous fluids, and etc.
So now we have reached the conclusion, where by having a clean environment, we can prevent the transmissions of the bacteria. We also need to wash our hands frequently and keep the sanitation neat around us to prevent the spread of CRE by people with the infections and the medic. Prevention is an important phase that used to minimize the spread of CRE. Thank you.